Welcome to the healthaibrief, breaking down the AI shaping our world one concept at a time. You're presenting a chest x-ray on a ward round. The senior expert doesn't just ask what do you see, they point, they trace the outline of a subtle consolidation with their finger and say, that's the pneumonia. They're teaching you by providing the answer, linking the visual pattern to the clinical diagnosis. So how do we teach a machine to do the same thing? It can't learn from experience in the same way we do, so how do we give an AI the ground truth it needs to learn to spot disease? The answer is a process called data annotation or labeling. It's a meticulous, often human-driven task of teaching an AI by showing it thousands of examples and explicitly telling it what's what. It's one of the most crucial, time-consuming and expensive parts of building a useful medical AI because you need experts in that area in order to train the model effectively. The best way to think about it is exactly like teaching that medical student. We wouldn't just give them a library of 100,000 anonymized x-rays and expect them to become a radiologist. We provide what's called supervised learning. We sit down with them and annotate. We point to an image and say, this is normal. We point to another and draw a circle around a lesion, labeling it malignant nodule. In the world of AI, this is done digitally. A team of expert clinicians, whether they're radiologists, pathologists, dermatologists, will sit and painstakingly draw boxes around tumours on CT scans, segment organs or tag regions of interest on a digital pathology slide. Each label is a piece of expert knowledge, a correct answer, the AI then uses to train itself. The algorithm analyses the pixels inside the box labelled tumour and learns the patterns, the textures, the shapes, the densities associated with that label. And after seeing thousands of expertly labelled examples, it can start to identify those patterns on its own in new, unseen images. The quality of the AI is therefore completely dependent on the quality of its teachers. If the labels are inaccurate, inconsistent, or ambiguous, the AI will learn these same flaws. So why does this matter if you're not building an AI yourself? First, when you appraise a study on a new AI tool, pay close attention to who did the labelling. Was it a panel of subspecialist consultants, or was it junior trainees, or kind of non-subspecialist experts? The expertise of the annotators is a direct proxy for the potential quality and reliability of the final model. Good papers are transparent about this process. Second, understand the source of AI uncertainty. If two expert radiologists disagree on the precise boundary of a lesion when labelling it, what we call the inter-rater variability, how can we expect an AI to be certain? The model's performance ceiling is often limited by the consensus or lack thereof among the human experts who taught it. And finally, this highlights a new and vital role for us. Data labeling isn't just an IT task. It's a form of digital age clinical practice. Contributing to high quality, expertly annotated data sets is one of the most important ways clinicians can shape the future of medicine and ensure the tools that we end up using are safe, accurate, and built on genuine clinical wisdom. And there's a growing effort among a lot of the frontier AI labs in hiring and looking for experts in their area to label data to train models. So that's data annotation and labeling in a nutshell. If you found this useful, don't forget to hit subscribe or follow in your podcast app so you don't miss future episodes.